Example 4. So for example 4, we're going to look at some problems from the textbook. So we're looking at number 23 from page 283. It says the integral from 0 to b of x dx, where b is greater than 0. This piece of information is very important because it tells us that the integral is going to be increasing in x values and not decreasing. So the first thing we want to do is break down this integral. And you notice that right here, this is our f of x. So our function then is f of x equal to x, which you know is a straight line. This is going to be our lower limit, and this is going to be our upper limit. And the dx right here tells us what we're integrating over. So we're integrating over the variable x. So the first thing we need to do is graph y equals x. So we start here at 0, 0. And we're going to graph y equals x. And it's going to look something like that. And we're going to integrate until a value b. So we choose any value b that's greater than 0. So I'll pick it to be right here. Here's b. It could be 1, 2, 3, 4, 10 million. I don't care. Just b. And remember, when we integrate, that means that we're finding the area underneath this curve y equals x. So what we're trying to find is the area that this triangle makes right here. So first, let's identify the coordinates of this point. The x value b is b, and the y value is f of b. Well, f of x is equal to x, so f of b is equal to b. So this coordinate is actually b comma b. So the width of this triangle is b, and the height of it is also b. So the area then of a triangle is 1/2 base times height. So the area is 1/2 b times b. So the area is 1/2 b squared. And that's it. So if you want to write that as an integral, it's from 0 to b of x dx is equal to b squared over 2. Okay, now on your own, I want you to try number 25 from page 283. Evaluate the integral from a to b of 2s with respect to s. Also notice that a and b are both larger than 0 and a is less than b. So go ahead on your own, try this now. Okay, so the first thing we need to do is graph this. The reason I only drew the first quadrant is because we're dealing with a and b greater than 0, so we're not going to deal with anything less than that. So the first thing we need to do is graph it. So we know it's 2s, so it's going to be like here, something like that. And we need to integrate from points a to b, so we're going to choose any random point a and any random point b. So I choose my random point a right here. And it's going to correspond with that coordinate. And I'll choose any random point b, and that one's going to be right here. And we draw that up, and you get something like that. So our goal then is to find the area underneath this curve. So there's two ways to solve this. You'll notice that you've got a trapezoid here. So way one is finding the area of this trapezoid. And the area of a trapezoid is 1/2 times height times the average of the bases. So the height for this is going to be this distance. So the height is b minus a. And the height here is going to be 2a. And the height here is going to be 2b. So times 2a plus 2b. And you get the area then is 1/2 b minus a. I'm going to factor out the 2, you get a plus b. And then the 2 is going to reduce out. So then you get b minus a times b plus a. And you get the area is b squared minus a squared. Now there is another way to do this problem. and that is to turn this into two shapes, one rectangle and one triangle. And if you do that, so we'll call this the two-shape way. Well, the area of the rectangle, so the area of the rectangle is going to be 2a times b minus a, and the area of the triangle is going to be b minus a times 1/2 times two b minus 2a. Because this distance is 2a, and I just want this distance. So this is going to be, I'm going to factor out the 2 again, so 1/2 b minus a times 2 times b minus a. 2's reduce, then you get b squared minus 2ab plus a squared. And here you're going to get 2ab minus 2a squared. Now we have to add them together. So you get 2ab minus 2a squared plus b squared minus 2ab plus a squared. These are going to cancel off, and I'm left with b squared minus a squared. So you get the same answer both ways.